Hi everyone, welcome back for today's class. Today we will continue applications of Gauss's theorem. Today we will discuss the third application. We will find the electric field near a uniformly charged thin spherical shell. So we are considering a uniformly charged thin spherical shell. Shell means inside is zero, right? Inside nothing is there. Inside charge is not there. Okay. So let us find the electric field due to the spherical shell. We will find the field inside, outside the shell, and at the surface of the shell. So first we imagine a uniformly charged spherical shell. See, this is a uniformly charged spherical shell. Charge is plus Q on the surface. This shell has a charge plus Q distributed uniformly over its surface. Here also, let us take sigma as the charge density, surface charge density. Let sigma be the surface charge density. You know, equation for surface charge density, sigma equals Q divided by A. Let capital R be the radius of this shell, radius of this spherical shell. So you can write Q as sigma into A. And what is the surface area of a spherical shell? You all know, 4 pi r square. Sigma equals 4 pi r square. So this is the charge on the surface of the shell. Now, let us find the electric field at a point inside the shell. Okay. Electric field at a point inside the shell. We are finding. So you imagine a point inside. This is the point P. At a distance small r. You know, to apply Gauss's theorem, we need a spherical shell. We need a Gaussian surface. So imagine a sphere of radius small r. Okay. So this is the Gaussian surface. I name this surface as 1. Now you can apply Gauss's theorem for this surface, closed surface, the inside surface, dotted line. I drew it by dotted line. So what is the Gauss's theorem equation? Phi is equal to closed integral E dot ds equals Q by epsilon 0. But what is the charge enclosed by the inside sphere in spherical surface? See, I have drawn a sphere with the dotted line. That is a Gaussian surface, right? What is the charge enclosed by it? No charge is enclosed. So charge enclosed is 0. So electric field inside is 0. Okay. So electric field inside the spherical shell is 0 because no charge inside. In the same way, if you find the electric field in any hollow cavity, electric field will be 0 because inside the cavity no charge will come. Otherwise, we have to place charge. Okay, so inside a hollow shell, hollow conductor, everything, electric field is 0. This phenomenon is known as electrostatic shielding. Now, let us find the electric field outside the shell. Okay, electric field outside the shell. Electric field outside the shell. For that, you imagine a point outside P. Now you consider a point outside the shell at a distance r from its center. At a distance small r from its center. This distance is r, small r. Okay. Now you have to draw a Gaussian surface passing through that point. So to apply Boses theorem, you need a closed surface. So you imagine a spherical surface passing through that point. Okay. So I am drawing a spherical surface passing through that point. Okay. Imagine a small area dA surrounding this point. You know, electric field is outward. You know, charge is positive. Electric field is directed away. For this small area dA or ds, take area as ds. ds is the small elementary area. ds direction is also outward. Okay. So here electric field and ds are in the same direction. Area vector are in the same direction. So here Gaussian surface is that black spherical shell. The spherical shell drawn with black ink, the bigger one, that is the Gaussian surface. Now you can apply Gauss's theorem. What is the equation? Phi is equal to closed integral E dot ds. Closed integral E ds on this shell, electric field and area vectors in the same direction, cos 0. So it will be closed integral E ds. E is constant, integral ds. See, what is this integral ds? See, children, you can see ds is a small area on the Gaussian surface. When you integrate that small area, what you will get? The full surface area of the sphere you will get. So what is the surface area of a sphere? 4 pi r square, right? But here r is small r, right? But integral ds is 4 pi small r square. Small r is the radius of the Gaussian surface. Therefore, we can write phi is equal to E into, what is integral ds? 4 pi r square. Again, you know, phi is q by epsilon 0. E into 4 pi r square. And you can find out E from here. Q by 4 pi epsilon 0 r square. But Q you found out already in the first equation. First thing, what was sigma? Q by A. So it was Q. What is the value of Q? Sigma into 4 pi r square, right? That is capital R only, because charges are on this sphere of radius r only. So we can write E is equal to, instead of Q, 4 pi r square sigma divided by 4 pi epsilon 0 r square. If you cut 4 pi, you will get E as sigma r square by epsilon 0 r square. If you write in vector form, E hat will be sigma r square by epsilon 0 r square n hat. So this is the electric field at the surface of the spherical shell. So what is the electric field inside the shell? 0. Why 0? the Gaussian surface encloses no charge, right? That is why electric field inside the shell is 0. Outside it is sigma r square by epsilon 0 r square. Now you can see at the surface of the shell. See, you can use this equation only. E bar equals sigma r square by epsilon 0 r square. When you consider a point at the surface of the spherical shell, small r become equal to capital R, right? At the surface, you consider the Gaussian surface as the surface of the spherical shell. So radius of the Gaussian shell is same as radius of the shell, right? So we can write R equals capital R. So what will be electric field? E equals sigma by epsilon 0. Capital R square, small r square cancel. You will get into n hat. Okay. So what is the electric field inside a spherical shell? 0. What is the value of electric field at the surface of a spherical shell? Sigma by epsilon 0. Outside it is sigma r square by epsilon 0 r square. Now, children, now we can plot the variation of electric field with the distance from the center of the shell. Let us see how the field graph look like. Okay. See, I take electric field along y-axis, distance along x-axis. You know, inside the shell, you consider a shell from center till the surface, till rate distance r, electric field is 0. So we can, in the graph, you can represent electric field is 0 till this distance capital R. And at the surface, what is the electric field? Sigma by epsilon 0. That is a constant only. And you move away from the surface. What is the equation for electric field outside the surface? Sigma r square by epsilon 0 r square. Sigma capital R epsilon 0 r constant. So E proportional to 1 by r square only, right? So outside the surface, electric field is inversely proportional to r square. So how will we plot the graph? You know, till r, electric field is 0. So you mark the point here on the x-axis itself. At the surface, electric field is sigma by epsilon 0. Okay. And as you move away, what will happen? Electric field will decrease. Okay. So this is the graph. Okay. This is the graph. From the surface, electric field goes on decreasing. Inside the surface, electric field is 0. Okay. So in the previous two lessons and in this lesson, we discussed applications of Boses theorem. These three applications are very important for the examination point of view. Board exam questions will be asked repeatedly. It is asked. Okay. And these graphs are also important. Graph can be asked for short answer for 1 mark or as a subdivision of a 2 mark or 3 mark question. So learn it, children. Now we will do a textbook question. Okay, based on this Gauss's theorem. Textbook question. I will give the question. This is the example question of your NCERT book. Okay, I will give the question. See, let us solve this question. Electric field components in the figure are, figure is given, figure also I will give you. See, read the question. Electric field components in the figure are Ex is equal to alpha x raised to 1 by 2. Ey Ez is 0. Alpha given 800 Newton per coulomb per meter square. Calculate the flux through the cube. Charge within the cube. Assume that A is 0.1 meter. See the question. Here electric field is given Ex equals alpha x raised to 1 by 2. Ex means electric field is along x direction only. It is given electric field along y direction 0. Electric field along z direction 0. That means no flux pass through y and z direction. Okay. So no flux through y and z directions. So when you consider the cube, there is no flux along y direction and there is no flux along x direction. Only flux, sorry, no flux along z direction. No flux along y direction, no flux along z direction. There will be flux along x direction only. And Ex is given. Okay. And alpha given. Alpha is a constant. So we can write Ex as, instead of alpha, you write 800 x raised to 1 by 2. Right? This is the electric field, right? Now see the figure. See, you know this cube, there are two faces on the x-axis. Left face you can see, and writing this as left face, the other one as right face. This is right face, right? Okay. Electric field is along the positive x direction only. You can see some flux will be entering through the left face and some flux will be leaving through the right face. I am finding flux through the left face, phi L. Okay. Phi L, flux through the left face. What is the equation? E dot A, right? E A cos theta. Now look at the left face. Electric field is towards right, right? Electric field is towards right along the positive x direction. But normal to the left face, outward normal is the direction of area. So area direction is in this way. Okay. Normal is the direction of area. It is shown there NL. So area direction is outward, opposite to electric field. So what will be theta here? 180 degree. So you can write flux through the left face is EA cos 180. What is cos 180? Minus 1. So EA into minus 1. Okay. EA. So what is the equation for electric field? See EXA. X is subscript. What is electric field EX? 800 into x raised to 1 by 2 into area into minus 1. This is the flux through the left face. Now, one more thing, you look, what is the x coordinate of the left face? See this A. A is written there. See this A. Distance from the origin to the left face is A, right? So x coordinate for left face is what? A. See here, x coordinate for the left face, it is A, given as A. It is shown in the diagram. This distance is A. So you can write here minus 800 into x is what? A raised to 1 by 2 into area. Area means area of the face. You know, side is so cube length is A. So what is the area of one face? Left face, A square only. So you write A square. Okay. This is the flux through the left face. Newton meter square per coulomb. In the same way, you can find out the flux through right face. Equation is same. Ex A cos. See the right face. Electric field is along positive x direction. Normal to the surface. That is the area directions. Same direction. So electric field and area are same direction, theta 0. So you write A Ex A cos 0. Okay. Now, what is the electric field for right face? 800 into x raised to 1 by 2 into area into 1. Now, look in the figure. What is the x coordinate? X coordinate for the second phase, right phase. You know, from the origin to the second phase, the distance is this A plus A, 2A. So x coordinate for the second phase is 2A. I think you understood it. Length of the face is A. Then first phase is at a distance A from the origin. So what is the x coordinate for the second phase? 2A. So we can write this as 800 into, instead of x you write 2A raised to 1 by 2 into area. What is the area of the face? It is a square, A square into 1. Newton meter square per coulomb. So we found out flux through left face and flux through right face. So what will be the total flux? You just add it. So total flux. What is total flux? Phi is equal to, add it. Phi left plus phi right. What was the phi left? Minus 800 into A raised to 1 by 2 into A square, right? Plus, what is the flux through right side? 800 into 2A raised to whole raised to 1 by 2 A square into 1, right? Is equal to minus 800 into, what is A raised to 1 by 2 into A square? A raised to 5 by 2 plus 800 into, what is 2 raised to 1 by 2? You know, 2 raised to half is root 2. So root 2 into, here A raised to half into A square, A raised to 5 by 2. Okay. Again, simplify. You can take 800 common, A raised to 5 by 2 common, remaining is, first term you get minus 1 plus second term you will get root 2. So what will be the answer? 800 into minus 1 plus root 2 into A raised to 1 5 by 2. See, A is given. What is A? In the question, it is given. Last part of the question, A is 0.1. So you have to put A as 0.1. So you are getting 800 into minus 1 plus 1.414 into what is A? This is A raised to 5 by 2, right? A raised to 5 by 2, 0.1 raised to 5 by 2. So it is 800 into 0.414 into 0.1 raised to 5 by 2. When you simplify, you will get the answer for the flux. So you have to calculate. This answer, when you calculate, you will get 1.05. So this was the first question. What was the question? They asked you to calculate the question A. Calculate the flux through the cube. So what was the question? Flux through the cube. Okay. What is the second question? What is a charge inside within the cube? And you know now how to find out charge. Apply Gauss's theorem. You know the flux. So phi equals Q by epsilon 0. So what is charge? Phi epsilon 0. Phi you determined as 1.05 into 8.854 into 10 raised to minus 12. So calculate, you will get the charge. Charge answer is 9.27 into 10 raised to minus 12. When you multiply this, you will get 9.27 into 10 raised to minus 12 coulomb. So this is the equation, this is the charge. So this question also important. This type of question is important. Okay. So we will do one more question from textbook. One more example from textbook I will give you. Okay. Read the question. First thing, when you are given a question, read it, understand it. Okay, write it, given data, think and solve. So first you read the question. An electric field is uniform and in the positive x direction, and uniform with same magnitude but in the negative x direction for negative. E equals, it is given E is 200 I hat for x greater than 0. X greater than 0 means along x axis. And E is minus 200 I Newton per coulomb, x less than 0. That is along negative x direction. A right circular cylinder of length 20 centimeter, radius 5 centimeter, has its center at the origin and its axis along the x-axis, so that one face is at x equal 10 centimeter and other is at x equals minus 10 centimeter. What is the net outward flux through each flat face? What is the flux through the side of the cylinder? What is the net outward flux through the cylinder? What is the net charge inside the cylinder? Okay, so first read and understand the question. See here, a right circular cylinder is given. So first to draw right circular cylinder. See, this is a right circular cylinder. Okay. You have to draw X and Y axis. Y axis, X axis, right? Now, what all thing is given? It is given that E is 200 I hat for X greater than 0. That means in this direction, along X direction, electric field is 200. Okay. I hat means for positive X direction. And for negative X direction, from this in negative X axis, this one. Here electric field is minus 200. It is given. And radius of this face is 5 centimeter. Okay. And what else is given? One face is at 10 centimeter. That means this is the first flat face. This flat face, this distance is 10 centimeter. And this distance is minus 10 centimeter. These are given. What is your question? First question, what is the net outward flux through each flat face? You can see there are two flat faces. Okay. On the right side, electric field along this direction, area vector also in the same direction. Okay. So what is the flux through each flat face? What is the equation? Flux equation is E into area into cos theta. E into area into cos 0, right? This is for right flat face. So we are finding flux through right flat face. What is that? E, you know, what is E? 200 into area. Area is, area of this flat face is circular area, pi r square. Cos 0 is 1. So 200 into 3.14 into, what is radius given? 5 centimeter. 5 into 10 raised to minus 2 square. This is the flux through right flat surface. Okay, that you have to calculate it. When you calculate, you are getting 1.57. Multiply, you get 1.57. Then when you consider the flux through left flat surface, see, electric field is along negative direction, X direction, normal also along negative direction. There also angle between electric field and area are same, 0 only, theta 0 only. So through the left face also, flat face also, you get the same thing, right? Flux through left face, phi L. It will be the same, E into A into cos 0, right? Electric field along negative direction, area also negative direction, they are in the same direction. That is why angle between them is 0. So you will get 1.7 Newton meter square per coulomb. That was the question A. Okay. Now, what is the question B? Read the question B. What is the flux through the side of the cylinder? Side means that curved surface. You know, there is no electric field along Y direction. So flux through Y direction is 0. So flux through the side of the cylinder will be 0, right? side of the cylinder. Phi equals E into A equals 0. What is the reason? Electric field along the y direction is 0. So flux is 0. Okay. Then they are asking what is a net outward flux. Net outward flux means you add all this. So C part net outward flux. Add the 3 fluxes. Okay. So you are adding, what are they? 1.57 plus 1.57 plus 0 is equal to 3.14 Newton meter square per coulomb. Last question, what is the net charge inside the cylinder? You need to find out the net charge inside the cylinder, D. So what is the equation? Phi is equal to Q by epsilon 0. So what is Q? Phi epsilon 0. Phi you already found. Just put the value 1.57 into what is epsilon 0? All of you know the epsilon 0 value. What is that? 8.854 into 10 raised to minus 12. You calculate, you will get the answer. On calculation, you will get Q as 2.78 into 10 raised to minus 11. Okay, children. So these type of numericals are very important. They may change that equation or values. Okay, very important. Practice yourself. Dear children, watch the video repeatedly, share it, subscribe it, give your comments. Thank you for all for watching. Okay, goodbye. See you in the next class. Thank you very much.